So hello everyone, welcome back to OLMJ, and today we'll be discussing the NSEP PYQs of laws of motion. This is the part 2. In the first part we covered from question 1 to question 19, and in this video we'll be covering from question 20 to question 39. So don't forget to like and comment if this video helped you, and I'll try to be more consistent from now and expect more solutions to be coming this week. So let's begin. Question 20 is from 2010 and it is a 12 marker question, so it is subjective. And it says that a block of mass 1.5 kg rests on a rough horizontal surface. A horizontal force applied to the block increases uniformly from 0 to 15 in 5 seconds. Determine the velocity and displacement of the block after 5 seconds. Okay. So, first let us analyze how the force is changing. So the force time graph is something like this, that it is increasing uniformly from 0 to 15. So this is 15 seconds, and at 15 seconds it is 5 newtons. At 5 seconds it is 15 newtons. So we can write the equation of this force in terms of time as, we can use the straight line equation 2-point form, and the equation will come out as, so y minus 0 is equal to 15 by 5 multiplied by time minus 0, which is t. So this will be F is equal to 3t. So this is how the force is changing with time. Okay, so this force is applied on the block of mass 1.5 kg. So 3t in this direction and 1.5 multiplied by g in downwards direction, and the normal due to contact with the ground. And till a certain point static friction will be acting on it. So let us first calculate the maximum value of static friction. That will be mu s multiplied by mg, which is 6 by 10 multiplied by 10 multiplied by 1.5. So the maximum value is 1.5 multiplied by 6, which is equal to, so 1.5 multiplied by 6 gives us 9 newtons. So till this force is less than 9 newtons, till 3t is less than 9 newtons, then friction will be equal to the force, right? Because static friction is self-adjusting. And once this force becomes more than 9, then kinetic friction will start acting. And kinetic friction is 0.5 multiplied by 15. So this is 7.5. Right? Let me erase this calculation. So the block starts moving when force, which is equal to 3t, becomes more than 9 newtons. This implies that the block will start moving if t is greater than 3 seconds, right? So now they are asking for the displacement of the block after 5 seconds and velocity. So we can write that the acceleration after 3 seconds will be given by 3t minus the kinetic friction, which is 3t minus 7.5. This is the acceleration, right? Sorry, acceleration multiplied by mass. So we will get that acceleration, which is equal to dv by dt, is given as 3t minus 7.5 divided by 1.5. So now we can find the velocity after 5 seconds. So dv at 3 seconds it is at rest. So and at 5 seconds let us assume the velocity is v. This will be 2t minus 5 from 3 seconds to 5 seconds. It is important to set this limit as 3 because before 3 seconds this will not be the acceleration. Kinetic friction will not be acting before 3 seconds. It will be static friction. So this is the acceleration only after 3 seconds. So we will write 3 over here as the lower limit multiplied by dt. So on integration we will get that v is equal to 2t square minus 5t from 3 to 5, right? So we will get v is equal to, sorry, there will be 2 in the denominator also, so this will get cancelled. So we'll get 25 minus 25 minus 9 minus 15, which will be equal to 6 meter per second. So this is the velocity at time is equal to 5 seconds. Now they are also asking for the displacement after 5 seconds, right? So one thing that we have to be careful about is that we don't have to forget the constant, right? Because here we had put limits, but if we find out velocity at any random point in terms of t, then what we will do that we will write it as dv by dt is equal to 2t minus 5, and if we integrate this without limits we will get v is equal to t square minus 5t plus c, right? And we know that at t is equal to 3 seconds the velocity is 0. So So 0 is equal to 9 minus 15 plus c, which will give us c as 6. So the actual formula of velocity is t square minus 5t plus 6, right? Here we did not write the constant because anyways the constant will get eliminated in definite integration. But here we are doing indefinite integration to find the general formula of velocity at any point, right? So now we can write this velocity as ds by dt is equal to t square minus 5t plus 6. This will give us ds from, if we assume that the displacement at time is equal to 3 seconds is 0 and at time is equal to 5 seconds it is s. So t square minus 5t plus 6 dt from 3 to 5. So we will get that s is equal to 14 by 3 meters or 4.67 meters. So hope this question is clear. Don't forget the constant while finding out the general formula of velocity, because if we don't put the constant then at t is equal to 3 we won't get that it is equal to 0 velocity, right? So it is important that we put a constant also. Now moving on to the next question, it says that an elevator of mass m, capital M, is accelerated upwards by applying a force F. A mass small m initially situated at a height of 1 meter above the floor of the elevator is falling freely. It will hit the floor of the elevator after time equal to. Okay, so the situation is something like this. This is an elevator of mass capital M and mass m situated 1 meter above the floor of the elevator. This has mass small m and the lift is accelerated upwards by applying a force of F. So here we have to assume the F as the total upwards force, right? Not F minus mg. The total upward force is given here, which is F, because it is written that it is accelerated upwards by applying a force F. So we will assume that F is equal to ma, not F minus mg is equal to ma. So acceleration will be F by m. So if we go in a non-inertial frame, then we can assume that a pseudo force of F by capital M multiplied by small m is acting downwards, and mg is either ways acting downwards in every frame. So the acceleration of small m would be mg plus F by m small m divided by small m, which is g plus F by m. So now it has to cover 1 meters with respect to the lift, because lift is stationary now. So S, which is 1 meter in downwards direction, is equal to ut, u is 0, half g plus fm in minus j direction t square. So this will give us 2m divided by mg plus f whole root is equal to the time, which will finally give us, sorry, this was capital M, right? This will be capital M and this will be capital M. So the answer is option D. Hope this is clear, that we will take this force as the total upwards acceleration, total upwards force, else you will get the wrong answer if you take F minus mg. So moving on to the next question. This is also a good question, a 12-marker question from 2011. So one end of a string is attached to a rigid wall at point O, passes over a smooth pulley and carries a hanger S of mass m at its other end. Another object P of mass m is suspended from a light ring that can slide without friction along the string as shown in the figure. OA is horizontal. Find the additional mass to be attached to the hanger S to raise the object P by 10 centimeter. Okay. So initially what was happening, that a tension will be acting here and here, and initially the system can be assumed to be in equilibrium. Okay, so tension will be acting upwards also here, and the mass of S is m and this is also m. So we can write the equations that this angle I am assuming as theta, so 2t cos theta will be equal to mg, right? And also t is equal to mg. So we will get that 2 mg cos theta is equal to mg. So cos theta is equal to half, which implies that theta is equal to 60 degrees, right? So this angle is 60 degrees. So we will get that this half length will be 20 root 3. This will be 60 degrees. So tan 60, which is root 3, is equal to 20 root 3 by this height. So height will come out as 20 meters, right? Initially. So when height becomes 10 meters, then the situation will be something like this. There will be some theta which has changed. It will be 20 root 3, this will be 10. So I can say that this length will be square root of 400 multiplied by 3, which is 1200, plus 100, which is root 1300, right? Meters. So now what they're asking is additional mass to be attached to the hanger, so as to raise the object P by 10 centimeters. So after the object has raised 10 centimeter, the height is 10 centimeter and this length will be root 1300, and we are assuming that after it has raised 10 centimeter, then also it is at equilibrium, right? then only we need to raise the mass so that the system is in equilibrium. So now the equations will be 2t cos theta is equal to capital Mg, because the mass of P has not increased, and now T will become m plus mg, small m, which we have to find, right? So 2 multiplied by m plus mg cos theta is equal to mg, and cos theta we can find out as 10 by root 1300, right? So 2m plus mg 10 by root 1300 is equal to capital Mg. Okay, so now it will be 2m plus m is equal to root 1300 by 10 m. So this 100 inside the root can be taken out and it will become 10. So this will get cancelled with this. So this is root 13m, capital M. So m will be root 13m minus 2m. Right? Sorry, this will be 2 also. So 2 here. So the final answer is m multiplied by root 13 minus 2 by 2, which is approximately equal to 0.9 times of m. So we need to find, we need to add almost the equal weight. So this will become 2m almost, right? A little bit less than 2m, so that this has raised by 10 and it is still at equilibrium. So this was a nice question. So moving on to the next question, question 23. It says that two identical bodies M2 and M3, each of 4 kg, tied to a massless inextensible string which is made to pass around the pulleys P1 and P2 as shown in the figure. Angle ABC is 37 degrees. The coefficient of kinetic friction between the bodies and the surface on which the slide is 0.25. So if the body M1 moves with uniform speed, neglect the mass of friction and pulleys. Neglect the masses and frictions of the pulleys. So we have to find the value of M1. Okay, so this is 4 kg. This is 4 kg. And angle, this is 37 degrees, it is given. And the coefficient of kinetic friction between bodies and surface is 0.25. Right. So how we will solve this question is that first we can assume that tension is here T. So here also it will be T. And this is a different string, so tension will be different here. So I'm assuming that this tension is T dash, so this will also be T dash. So the first equation which I can write is M1G is equal to T, right? And since it is moving with uniform speed, so I have written this because acceleration will be 0 since speed is constant. Since mass m1 is moving downwards with uniform velocity, so sorry, this was downwards, so this m2 will be also moving in this direction with uniform velocity, right? By a string constraint, we can find that the amount which this string will extend, this string also has to extend by the same amount. So this will also have 0 acceleration, and since this is moving in this direction, so the friction will be acting in downwards direction, down the plane, down the incline. So I can write T is equal to m2g sine theta plus mu m2g cos theta plus T dash. And now for m3 I can write that since this m3 is also moving with uniform velocity, this will have 0 acceleration, so T dash in this direction and friction in this direction, so T dash will be mu m3g, right? So now putting this and this in this equation, I will get m1g is equal to m2g sine theta plus mu m2g cos theta plus mu m3g. And from here, if I put the values, then m1 will come out as 4.2 kg. So option C is correct. Okay, so question 24 says, two bodies A and B hanging in air are tied to the ends of a string which passes over a frictionless pulley. The pulley and string are massless and the masses of the A and B are 2 kg and 3 kg respectively. So body A moves upwards under a force equal to. So if this is the pulley, this is body B, which is 3 kg, and this is body A, which is 2 kg. So since this mass is greater than 2 kg, so this will be moving downwards and this will be moving upwards with the same acceleration due to string constraints. So 30 will be acting downwards, T will be upwards, and 20 will be acting downwards, T will be upwards, and an acceleration would be upwards. So we can write that T minus 20 is equal to 2a and 30 minus T is equal to 3a. So from here, if we add these two equations, we will get that 10 is equal to 5a, which gives us the acceleration as 2 meter per second square. Further, if we need to find the tension, right, because the total upward force it is being asked, right? So T minus 20 is what the answer will be. So T can be obtained from here. If we put 5 here, this will become 15. So T will become 30 minus 15, which is 15 newtons. Right? Sorry, this will be 6. So 30 minus 6 will be 24 newtons. And the total upwards force on this will be 24 minus 20, which is 4 newtons. So the answer is equal to option D, which is 4 newtons. We can also look at it in a different way, that since the total upwards acceleration is 2 newtons, so we know that F external is equal to mass multiplied by A. So the total upwards force will be 2 multiplied by 2, which is 4 newtons. So we are getting the same answer from this concept also. This will reduce the calculation. So the answer is option D. So moving on to question 25, it says that masses m1 and m2 are connected to a string passing over a pulley as shown, and mass m1 starts falling from rest and falls to a distance d in time t. Now by interchanging the masses, the time required for m2 to fall through the same distance is 2t. So we have to find the ratio of the masses. Okay, so in case 1, we can write that if this is moving downwards with acceleration a and this is moving in this direction with a, and the tension will be same because it is the same string and this massless string. So m1g minus t is equal to m1a, t minus m2g sine theta is equal to m2a. So from here, if we add these two equations, we'll get the acceleration m1 minus m2g sine 30 is half, so divided by m1 plus m2 is the acceleration. So the time required to fall through a distance d will be calculated as d is equal to s is equal to ut plus, since u is 0, so half 2 m1 minus m2 by 2 m1 plus m2 g t square. So the time will be 4d m1 plus m2 divided by 2 m1 minus m2 g whole root. And in the second case, if we interchange the masses, then simply in this acceleration the masses will get interchanged, right? So we will get the acceleration as m2 minus m1 by 2g divided by m1 plus m2. So the time will be, simply interchange the two masses. So we will get 4d m1 plus m2, 2m2 minus m1 by g. So this t dash is 2 times of this time, right? So t dash by t is equal to 2, which is basically equal to, since this numerator is equal, so only the denominator will remain. So this denominator will come here and this denominator will be here. So if we square both sides, we will get 4 multiplied by 2m2 minus m1 is equal to 2m1 minus m2. So we will get 8m2 plus m2 is equal to 2m1 plus 4m1. So 9m2 is equal to 6m1. So we are asked the m1 by m2. So m1 by m2 will be 9 by 6, which is equal to 3 by 2. So the answer for this question will be 3 by 2, which is option B. So this was a easy or moderate question, not very conceptually rich, but it was a bit lengthy. So question 26 says a pulley of negligible mass is suspended from a spring balance. Blocks weighing 5 kg and 3 kg are attached to the two ends of the string passing over the pulley. So the reading in the balance will be, so assume that the balance is here and pulley is attached. This should be negligible pulley, negligible mass pulley. So 5 kg here and 3 kg here. So tension will be acting in upwards direction on the blocks. This will be 50. So since this is greater than 3, so acceleration will be in this direction and this direction. So we can write, and since this pulley is massless, so the force on it should be 0, because we know that F external is equal to mass into acceleration. So acceleration is equal to F external by mass, and since this is tending to 0, then if this does not tend to 0, then acceleration will be infinite. So this should be of 0 by 0 form for acceleration to be finite. Hope this makes sense. So this will be 2t. So the force acting on the reading of spring will be 2t. So we essentially need to calculate 2t. So t minus 30 is equal to 3a and 50 minus t is equal to 5a. And from here we will get, so on adding these two equations, we will get 20 is equal to 8a. So the acceleration will come out as 20 by 8, which is equal to 5 by 2, which is 2.5 meter per second square. So if we put 2.5 here, we'll get 7.5. So tension will be 37.5. So 2 times of this tension will be 37.5 multiplied by 2, which is equal to 75. So the reading will show 2t by g, since 2t will be the equivalent mass of this now. So 2t by g, which will give us the mass, which is 7.5 approximately. So the answer will be 7.5. So question 27 says two blocks of masses m1, m and 2m are placed on a smooth horizontal surface as shown. In the first case, only a force F1 is applied from the left. Later on, F2 is applied from the right. If the force acting at the interface of the two blocks in the two cases same, then F1 to F2 is asked. So first we are applying only F1 from the left and later F2 only. Okay, so in the first case, the combined acceleration will be if we treat this as a system, so it will be F1 by 3m. So the normal here will be responsible for pushing this m, and since that will be the only external force, that should be equal to ma. So normal will be m multiplied by F1 by 3m. So normal 1 is F1 by 3, and in the second case, the total acceleration will be F2 by 3m, and since in this direction this normal will be in this direction for 2m, and this will be only the external force on 2m, so this should be equal to ma. So n2 should be equal to 2m multiplied by F2 by 3m, and since these are equal, so 2 by 3 F2 is equal to F1 by 3. So F1 by F2 will come out as 2 by 1. So the answer is option C. Moving on to question 28, it says that two blocks of masses 8 kg and 7 kg are connected by a light spring passing over a frictionless pulley. The masses m1 is at rest on the inclined plane and m2 hangs vertically. The angle of inclination is 30 degrees. So the friction force acting on m1 is okay. So mass m1 is here with 8 kg, and this mass is hanging vertically. This angle is 30 degrees and this system is at rest, right? So tension will be acting here and tension will be acting here 70, and since this is at rest, so tension will be 70 newtons, and in this direction it will be 80 by 2, 80 sine 30, which is 40, and a friction also, let me assume the friction as 30. So T should be equal to T, which is equal to 70, should be equal to 40 plus X, since this block is at rest. So X will come out as 30 newtons down the plane. So the answer is option B. This was easy question. So question 29 says a body of mass 4 kg moves under the action of a force 4 I cap plus 12 t square j cap newtons, where t is the time in second. The initial velocity of the particle is 2 I cap plus 1 j cap plus 2 k cap meter per second. If the force is applied for 1 second, then we have to find the work done. Okay, so this is a nice question and we can solve it by two methods. And the first method is more of a kinematical method, and the second method is related to impulse momentum. So let us see the first method first. So the force, which is equal to mass into acceleration, is given as 4 I cap plus 12 t square j cap. So from here we can find out that the acceleration will be, since the mass is 4 kg, so we'll divide this by 4, so we'll get acceleration as I cap plus 3t square j cap. So from here we can find out the velocity. So we can write this acceleration as dv by dt, and we can take this dt here and then integrate to find dv. So dv from 2 I cap plus j cap plus 2k cap to some vx I cap plus vy j cap plus vk k cap. So we integrate this from this to this, and then on the other side we will get I cap plus 3t square j cap dt from 0 to anytime t. From here we'll get vx I cap plus vy j cap plus vk k cap minus of 2 I cap plus j cap plus 2k cap is equal to, this will become t and this will become t cube by 3, and this 3 will get cancelled, so you get t I cap plus t cube j cap, right? So velocity at any time t can be given as, if we take this term on the right hand side, we'll get vx I cap plus vy j cap plus vk k cap is equal to t plus 2 I cap plus t cube plus 1 j cap plus 2k cap, right? So this is the velocity in terms of time. So now if this is the total velocity, we can write it as v vector. So now we can find out the displacement ds, because we know that work done is given as integration of f dot ds, right? So we need to find the ds. So we can write v as ds by dt. So ds will become t plus 2 I cap plus t cube plus 1 j cap plus 2k cap multiplied by dt. From here we can take the dot product with f and then we can integrate it. So work done will be from 0 to 1. Force was given as 4 I cap plus 12t square j cap. So 4 I cap plus 12t square j cap dot product with this ds, which is t plus 2 I cap plus t cube plus 1 j cap plus 2k cap dt. So if we take dot product, it will give us from 0 to 1 4t plus 2 I cap plus, so this will become 12t raised to power 5 plus 12t square j cap, and since there is no k component, so 0 multiplied by 2 will give us 0 k cap, so I am not writing it. So on integration we will get here we will get, since we have taken dot product, so this I and j won't be there, sorry. So we can now take the integration, so it will be 4t square by 2 plus 8t plus divide by 6 plus 12t cube by 3 from 0 to 1, and this will finally give us the answer as 16. So this is the work done, which is 16 from 0 second to 1 second. So the answer will be 16. Now we can see this by one more method. So method 2 is based on the fact that momentum change is given by the integration of this f dt, which is the impulse. So f dot dt is given as the change in momentum. So from 0 to 1 we can integrate it, 4 I cap plus 12t square j cap dt. So this will give us m multiplied by v final minus v initial, right? We are finding the v final and v initial because the change in kinetic energy is equal to the work done right here. So we can find the change in kinetic energy, and for that we need to find the initial and final velocities. So this will give us (4t I cap plus 4t cube j cap is equal to m multiplied by v final minus v initial is given as 2 I cap plus j cap plus 2k cap, right? So we can find the final velocity from here. So this was 4, so dividing this by 4, this constant will get cancelled. So 2 I cap plus t cube j cap is equal to v final, and if we take this on the right hand side, then it will become t plus 2 I cap t cube plus 1 j cap plus 2k cap, right? So we have found the v final. If we put 1 here, then we'll get the velocity at 1 second, and you can see that this was also the v that we got here, and then we applied this formula. But we could have applied this formula also, that the change in kinetic energy will be, since the we have to find at 1 second, so v final at t is equal to 1 second would be 3 I cap plus 2j cap plus 2k cap, and the magnitude of v final at t is equal to 1 would be 9 plus 4 plus 4, which is given as root 17, and the v initial, modulus of v initial was root of 4 plus 4 plus 1, which is root 9. So change in kinetic energy would be half into 4 v final which ka square, which is 17, and v initial square, which is 9. So from here also you will get that 16 joule is the answer, because the change in kinetic energy would be the work done. So 16 joule is the correct answer. So we have solved this by 2 methods. Here also you could have applied the kinetic energy method, but here we applied this f.ds method. Okay, so essentially we have solved this by 4 methods. Okay, so question 30 is a very nice question from 2018, and it says that a constant force capital F applied to the lower block of mass 15 kgs makes it slide between the upper block of mass 5 kg and the table below as shown. The coefficients of static friction and kinetic friction between the lower block and the table are 0.5, and the kinetic coefficient is 0.4, and between the two blocks the static friction is 0.3 and the kinetic friction is 0.1. So the acceleration of the upper and lower blocks are respectively. So we need to analyze this case by case. So the first case would be when none of the blocks are moving. The force is so small that none of the blocks are moving. So in that case, the friction between 5 and 15 kg would be 0, because there is no impending relative motion or relative motion. And between the 15 kg and the floor, it would be static friction. So the maximum static friction between lower block and floor would be equal to the mu s, which is 0.5, multiplied by the total sum of the masses, because this 5 kg mass would also be exerting a normal force here. So the normal force which is here would be this normal force would also be contributing to the normal force which the floor is exerting on the 15 kg block. So total 20 kgs we'll take, and g we'll take as 10. So this will be 100 newtons. So 100 newtons is the maximum static friction between 15 kg and the floor. So if the F is less than 100 newtons, none of the blocks will move, right? Now assume that the second case is when you exceed the force by 100 newtons and it is still less than some value, then both the blocks will move and there will be no relative motion between 15 and 5 kg. So the acceleration of both the blocks will be same. So kinetic friction would be acting here because the 15 kg block is sliding, and static friction will be acting here since there is no relative motion but there is impending relative motion. So here the maximum acceleration of this 5 kg block can be the maximum static force divided by the mass, right? So maximum acceleration of 5 kg block such that both blocks move together would be given by the maximum static friction between two blocks divided by the mass of the upper block, which is 5 kg. So this would be mu s, which is 0.3, multiplied by the mass multiplied by 10 divided by 5. So the maximum acceleration of the 5 kg block such that both the blocks move together is 3 meter per second square. So the maximum combined acceleration would be this much, and the force on the entire system, 5 plus 15 kg, is a force in this direction plus kinetic friction in this direction. So F minus mu k 20g would be equal to 3 newtons. We are finding this force which we will put here, such that the maximum force below which both the blocks will be moving together. So this will give us 3 plus mu k is given as 4 by 10. So 20 multiplied by 10. So this is coming out at 83. So since this is lesser than 100, so this means that for no value of force, both blocks can move together. Okay. Now the third case, when the force is greater than 100 newtons, both blocks cannot move together. So the next case is that there will be slipping between the blocks. This means that both the blocks will be moving forward but with different accelerations. So since at both surfaces there is slipping, so kinetic friction will be acting on both the surfaces. So on the upper block, kinetic friction would be in this direction, because if we check the relative motion without friction, then the relative motion, if this 15 kg is at rest, then this 5 kg will be moving backwards by pseudo force. So the friction will be acting in this direction to take it further, right? So friction will be in this direction, and this friction would be constant, since kinetic friction is constant, which is approximately 1 by 10 multiplied by 5 multiplied by 10. So this will be maximum kinetic friction is this much, which is 5 Newton. So acceleration of this block would be 5 by 5, which is 1 Newton, approximately 1 Newton. It will be a bit lesser than 1 Newton because G is 9.8, not 10. And on the lower block, kinetic friction because of the upper block, it will be acting in this direction. And because of the kinetic friction between the lower block and the floor, it would be 80 newtons. So 80 in this direction. So there would be a force in this direction. So force minus 85 by 15 is the acceleration, right? So since this acceleration is fixed now, so 1 Newton should be in the option. Oh, sorry, 1 meter per second square. So this is wrong because this is greater than 1 and this is approximately equal to 1. So C and D can be the answer. Now we'll check for 0.49 and 1.96. So if the acceleration is 0.49, so F minus 85 by 15 is equal to 0.49. We'll take it approximately as half because we took G as 10, so we'll take it as half. So this will be 2F minus 170 is equal to 15, which gives us 2F is equal to 185. So F is 92.5, which is less than 100. So this is not possible because in this case force was greater than 100 newtons, right? So C option is also wrong. This was wrong because both cannot have the same acceleration. We just checked, right? So D option can be right. Let us check. So if F minus 85 by 15 is equal to approximately 2, then it would be 30 plus 85, which is force would be equal to 30 plus 85, which is 115. So this is greater than 100 newtons. So D option is correct. Hope this question made sense, and if there is any doubt, then you can contact me on Telegram or leave a comment. I will explain the theory for such type of questions in detail. So now moving on to question 31, it says that a steel cable hanging vertically can support a maximum load W. The cable is cut to exactly half of its original length. The maximum load that it can support now is. So the maximum load which the cable can support has nothing to do with the length of the cable. It has to do with the material of the cable, which is same even after cutting. So the answer will remain W. So this was a conceptual question. And moving on to question 32, it says that a particle of mass small m is thrown vertically up with velocity u. Air exerts an opposing force of a constant magnitude s. The particle returns back to its point of projection with a velocity v after attaining maximum height h. Then, okay, so if we see, the particle has mg acting downwards and a force acting downwards also. So mg plus f will be acting downwards, right? So the net acceleration in downwards direction would be g plus s by m, right? So now we know that the particle is starting with velocity u, and at the highest point the velocity will be maximum. Velocity will be 0. So we can use the formula v square is equal to u square plus 2as. So v square is 0, u square, and this is in downward direction, so minus 2 g plus f by m h, where h is the maximum height. So on solving, we will get that h is equal to u square divided by 2 g plus f by m. Okay, so now one answer would be option A, and since this is a 6 marker question, so this is multiple options correct. So now let us find what will be u. So when the body is moving downwards, then the opposing force will move in upwards direction, right? This was when the body was moving upwards, right? But moving upwards. But here, since the body is moving downwards now, so the resistive force will be in upwards direction because it is an opposing force to the motion of the ball. So it will be in this direction and mg will be in this direction. So now the acceleration will be different from this case. It would be g minus f by m. So now, since the initial velocity was 0, final velocity we will find v square is equal to 0, and since v is also in downward direction and acceleration in downward direction, so I am taking downward direction as positive, so I'll write 2 g minus f by m h. From here we'll get that h is equal to v square by 2 g minus f by m. So this option is also correct. Now we need to find a relation between v and u. So we can equate the two formulae for h that we got. So we'll get u square by 2 g plus f by m is equal to v square by 2 g minus f by m. From here we'll get that v is equal to u square root of g minus f by m divided by g plus f by m. So the final answer would be A, B and C. So this was a nice question, and if you did not take the opposite direction for force, then you will do the question wrong. You should practice many types of problems where resistive force is acting. This is a very common question that comes nowadays. So let us move on to question 33. It says that a simplification of a kind of interlock is shown in the figure. All surfaces are smooth and frictionless. The body small m has a mass 1 kg and the block capital M is 15 kgs. So the time mass small m takes to reach the base of, if it is released at a height 4 meter above the base of m. So this is 4 meter. So we can see that on this block, let me draw the FBD of this block. So for capital M, this pulley can be assumed as connected to this block. So a tension is acting in this direction, tension is acting in this direction, and tension is also acting in this direction, and it has mg also. Sorry, it has capital Mg downwards, and normal due to this ground, and normal will be here also because these two blocks are in contact. So n dash in this direction, and for small m, mg will be in this direction, tension will be in this direction, and n dash will be in this direction. So if we assume the acceleration of this block to be in this direction, and so by normal constraint, the velocity of two bodies along the common normal should be same, and if we differentiate that, acceleration should be same along the common normal. So in this direction, this will also have capital A, and if it will also have a downwards acceleration, we can take it as relative acceleration, because if we put the wedge at rest, then this block would be moving only downwards. So the downwards acceleration can be assumed as relative acceleration. So we can use the virtual work method. So we'll get that t dot this a will give 0 because they are at 90 degrees, and this will give minus t ar and plus 2t a, because this tension in downwards direction will give 0 because they are at 90 degrees. This should be equal to 0. So from here we'll get that ar is equal to 2a. So this is actually 2a, right? So this 2a would be the acceleration which is covering this height, right? So we can start writing the equations to find a. So we'll get that 2t minus n dash is equal to ma, which is 15, and mg, so small m is 1, so we'll take it as 10. 10 minus t is equal to m2a, which is 2a since m is 1. So from here we'll get that and we can also write that this n dash is the only horizontal force, so this will be responsible for this a. So n dash will be equal to ma, which is only a since small m is 1. So I can use this here. So this will give me 2t is equal to 16a. So t is equal to 8a, and now I'll use this in this, so I'll get 10 is equal to 10a, which will give me a is equal to 1 meter per second square. So 2a is equal to 2 meter per second square. So 4 meter, which is in downward direction, is being covered with this acceleration. So minus 4j cap, and since this is starting with at rest, so u is 0, so half 2 minus j cap t square, which will finally give me that t is equal to 2 seconds. So this was a nice question, and you must have attempted such questions while you were preparing this chapter. So this is a standard question. So answer is C, 2 seconds. So moving on to question 34, it says that two small solid balls of masses m and small 8m are made up of the same material and tied at the two ends of a thin weightless thread. So they are dropped from a balloon in air. The tension T of thread during the fall after the motion of balls has reached steady state is. Okay. So the situation is something like this, that there is a thread and two balls are tied at each end. So if we assume that m is here and 8m is here, 8m will be downwards because it is heavier, so 8 mg will be acting here, tension will be acting here on this 8m, and on this small m tension will be acting here and mg will be here. So it is said that the balls have reached steady state, but here we can see that steady state is not possible because on this small m the only forces which are acting on small m are in downward direction, so this will have some net external force, and steady state means that there is no net external force, right? Because if there is no external force, then the velocity will be constant, which is the definition of steady state. So since the balls and the thread are in air, they are falling, so we have to assume that a resistive force due to the drag of the air is acting upwards, right? And we know that the resistive force, if this is a ball, then the resistive force would be acting on each point. So we can say that the resistive force is proportional to the radius. The resistive force is proportional to the radius, right? Because by Stokes' law, we know that it is equal to 8 pi neta RV. This you will study in fluids, that the resistive force is directly proportional to R. Okay, so we need to calculate the radius of both these blocks. And we know that since they are made of the same material, their density will be same. So M is equal to rho into volume. So rho can be given as M by this thing. So since the mass of this is 8 times, from first we'll get that R is equal to raised to power 1 by 3. So the radius is proportional to mass raised to power 1 by 3. And if we assume that the radius of this block is R and this is R dash, so R will be proportional to M1 by 3 and R dash will be proportional to 8M raised to power 1 by 3, which is proportional to 2M raised to power 1 by 3. So R by R dash would be equal to 1 by 2. So R dash is equal to 2R. So that means that the radius of this 8M ball is double the radius of this. So the force on this would be 2F, right? Because the force was proportional to R, right? So we can now write the equations. So we'll get 8mg minus T minus 2F is equal to 0, and mg plus T minus F is equal to 0. So if we add these equations, we'll get 9mg is equal to 3F. So F is equal to 3mg. This is the first result that we get. And now we have to find the tension. So we'll put F as 3mg here. So this will be 2mg minus T is equal to 0. So the tension will come out as 2mg. So this is the final answer. This was a nice question, and if you have read the fluid chapter, then it becomes even easier. So the answer will be A option. This was a very nice question. And so the next question is question 35. It says that a solid block of mass 3 kg is suspended from the bottom of a 5 kg block with the help of a rope of mass 2 kg. When pulled by upward force F, the whole system experiences an upwards acceleration of 2.19 meter per second square. So we have to choose the correct option. So since this rope has mass, the tension at each point won't be same, like we take the tension same in a massless rope at each point. Here the tension won't be same, because if we see, if this rope was at rest, here it is not at rest, it is moving with acceleration. But if we see at rest, then a tension would be acting here, mg would be acting downwards, and t dash would be acting here. So t dash must not be equal to t for equilibrium, right? So tension we cannot take same at each point. So keeping this in mind, let us draw the FBDs of each body. So the 5 kg block will experience 5g downwards, F upwards, and a tension downwards, right? This 2 kg rope would be experience this same T upwards, a T dash downwards, and 2g upwards, 2g downwards, and both are moving with acceleration, which is 2.19 upwards. Now the 3 kg block will experience 3g downwards, T dash upwards, and this T dash is same, and an acceleration upwards. So if we write the equation of each body, then we'll find out that F minus 5g minus T is equal to 5a. Okay, now for this rope, T minus 2g minus 3 dash is equal to 2a, and this 3 kg block, it will be T dash minus of 3g is equal to 3a. Okay, so now if we add these three equations, we'll find out that this t will get cancelled with this will get cancelled with this, and we'll be finally left with F minus 10g is equal to 10a. So F would be equal to 10a, which is 21.9, plus 9.8 multiplied by 10, which is 98. So this would be approximately equal to 120 newtons. So the force is 120 newtons. So C and D are wrong. So now we will check option A. It is saying that the net force on the rope AB is 24 newtons. So the net force on this AB is this, which is equal to 2A. So we can say that the net force on rope is equal to 2A, which will be equal to 2 times 2.19, right? So 2 times of 2.19 we have to calculate, which is equal to 4.38 newtons. So the net force on the rope is 4.38 newtons, and so this is wrong, right? So now we will calculate the tension at the midpoint of the rope AB. So this whole body, if we take the half rope of 1 kg, since the entire rope was 2 kg, so half rope will be of 1 kg. We are assuming that the mass is distributed uniformly in the rope. So half rope has mass 1 kg, and this block has mass 3 kg, and this would be pulled by a tension which we have to calculate, and downwards it will have 4 g's acting. So T minus 4 times g is equal to 4 times of A. So T is equal to 4 times of G plus A. So 4 times of 9.8 plus 2.19. So this will be approximately equal to 47.96 newtons. So this is approximately 48 only, right? 48 newtons. So option B is correct. So this was a nice question where the rope also had mass. So you have to be careful in such types of question that you do not have to take the tension same at each point. If it was a massless rope, the tension here and here would have been same, and there would be one less variable. Okay, so moving on to question 36. It says that a force 100 newtons is applied to a 3 kg block in contact with a vertical surface S as shown. The coefficient of friction between S and the block is 0.25. So we have to find out the friction force acting on the block and direction also. So it would be something like this. So the would be having a component perpendicular and parallel to this wall. So the component here would be F cos 30, which is root 3 by 2 F, and one component would be acting upwards, F by 2, and mg would be acting downwards, to 3g, and g we have to take 10, so it will be equal to 30 newtons downwards. And this is 100 newtons, so we can write this as 50 root 3 and 50 newtons. So since this force is greater than this force, so to keep this block in equilibrium, there should be a frictional force in downwards direction, right? So that we can have equilibrium in y direction. So B option would be wrong because C option and D option would be wrong because they are saying that the friction is acting upwards, which is wrong. So now we calculate the frictional force here. So the maximum static friction is mu times the normal, which is equal to 50 root 3, right? So we will get that this is approximately equal to 21.65. Okay, so now we will calculate the friction force that is actually required to keep the, we don't know if the body is in equilibrium or not, so we will calculate the force which we require to keep the body in equilibrium, and if that is less than this, so the body will be in equilibrium, and if that is more than the maximum static friction, then that won't be acting and we have to calculate the kinetic friction. Okay, so now let us calculate the frictional force required to keep body in equilibrium. So that is 50 minus 30, which is 20 newtons, and since this is less than 21.65 newtons, this is our correct answer. This would be acting, so the answer is option B. Hope this is clear. And moving on to the next question. With what force must the man pull the rope to hold the position platform P in position? Weight of the man is W, and we have to neglect the masses of the rope, pulley and the platform. Okay, so if we take the FBD of the man and the platform together, so one tension is acting here upwards, one tension is acting here upwards, and another tension is acting here, but this would be 2T, right? Because this is T and this is T, and since this pulley is massless, so the net force on this should be 0. I earlier explained why, to have a finite acceleration. So this would be 2T and this would be 2T. So 2T will be acting here. So 4T is equal to W. So the tension is equal to W by 4, and that is the force by which the man is pulling. So tension is the answer, which is option A. If we had considered this was method 1, and if we consider the FBDs of the man and the platform individually, so it would be that the man has W downwards and tension plus normal upwards. So T plus N is equal to W, and on this platform 3T is acting upwards, right? So 3T is equal to N, because platform would be something like this, that 2T is here, T is here, and N is downwards. So 3T is equal to N. So from here we can substitute this here, so we'll get 4T is equal to W, which we got here. So from here also we'll get the same answer. So if we take the correct system, which is the block and the man combined, then we can solve in less number of steps. So question 38 says that two blocks A and B of masses 10 kg and 20 kg respectively are connected by a spring. As a result of a force 200 newtons applied on the block B, the acceleration of the block B at any instant is 12 meters per second square towards the right. So it is moving with 12 meters per second square towards the right. So we have to tell the acceleration of A at that instant. So if we assume that the spring force is in this direction, then we'll find out that 200 minus kx is equal to 20 multiplied by 12, which is 240. So kx would be minus 40, which means that actually kx is not acting in this direction, and rather it is acting in this direction, which means that the spring is compressed because the force is outwards. So on this block 40 newtons would be acting this way, because kx would be acting in towards the left side because this spring is compressed. So the acceleration of 10 block would be 40 divided by 10, which is 4 meter per second square towards left. This was a rather simple question. So moving on to the next question. Question 39 says two blocks A and B of masses small m and 3m are placed on a smooth horizontal table. A massless and unstretchable string joining them hangs over the edge and supports a massless pulley, which itself carries a block of mass 2m C suspended by another string. The parts of the string on table are parallel and perpendicular to the edge of the table. The acceleration of block C is. Okay, so here we need to understand two things, that if this tension is T and this tension is T, then this tension needs to be 2T, right? Because this pulley is massless and the force on net external force on it should be 0. And also if this is moving with AB and this is moving with AA, so this point would also be moving down with AB and this would be moving with AA, and the acceleration of pulley is the average of the acceleration of the strings. So AC would be equal to AA plus AB by 2. This is a standard result which we can obtain using constraints. So now we can write the equations of the three bodies. So T minus, here there is no other external force in the horizontal direction, so T would be equal to 3m AB, and this T would be equal to, T would also be equal to m into AA. And for AC, now we can write that AC is equal to AA plus AB by 2, which we can obtain in terms of tension by these two equations. So T by 3m plus T by m by 2 is AC. So taking the LCM, this would become 4T by 6m, which is equal to 2T by 3m. So this is the acceleration, and now we will write the equation in y direction for 2m blocks. So 2T minus 2mg is equal to, sorry, we had assumed that this acceleration is in downward direction, so we should write 2mg first, because 2mg is also in the direction of acceleration. So 2mg minus 2t is equal to 2m AC, which is equal to 2m multiplied by 2t by 3m. So m and m get cancelled. This is 4t by 3. So 2mg is equal to 4t by 3 plus 2t. So taking the LCM, this would become 10t by 3. So this implies that tension is equal to 6 by 10 mg, which is 3 by 5 mg. So now we need to tell the acceleration. So we'll put this tension in this equation. So 2 mg minus 2 times 6 by 5 mg by 2m is equal to the acceleration. So this would be 4 by 5 mg by 2m, which is equal to 2 by 5g. So this is our answer for the acceleration of block C. So the correct answer is option D. So this was also a fairly decent question, and you might have noticed that as we move further away from the older years like 2008, before 2008, then the questions are getting easier and easier. So once we reach the recent years like 2023, 2024, the questions have become a bit easier compared to the questions that came in NSEP in 2003 or 2004. So now they are asking fairly simple questions, but now you have to solve them quickly. So you must keep revising formulas and ask any doubts that you have in the comment section. And don't forget to like and subscribe, and we'll meet soon again. So bye.